Okay guys, many thanks for being here. I have to apologize for my voice. I had my delivery in my training course the past 3 days. The only way to keep him shut is keep talking, so I overstressed it a little bit. My name is Drs I'm a VMware certified instructor. I am doing this on a freelance basis, so I'm training for all the VMware authorized training centers over Europe. This is my first time in London and I'm really happy to be here presenting at the London VMUG. It's a real honor. Module 1 will be about admission control policies and yeah, please come in because you have to stand in the back. Admission control policies deal with how many virtual machines you can power on within an HA cluster. And if you are going to configure an HA cluster, lots of people are enabling HA in the first place, and then after a while someone tries to power on a VM and they get the message that there are not enough resources available anymore, insufficient resources. Yeah. So the most configured admission control policy these days is disable, allow virtual machines to power on even if they violate the availability constraints. Why is that? Should you ask? Because people are not thinking about slot sizes. They just simply configure HA, they put in one host failure allowed, and that's it. But they don't realize that the slot size can be influenced, for instance, by reservations or by advanced HA settings. So in this case, people are getting this message, insufficient resources to satisfy the failover level for HA, and they just simply switch off AA. What happens then is that people are tending to power on more virtual machines than actually can be powered on, and in the end you will have a situation where one of the ESX hosts is going down and then virtual machines are not powered on the other hosts anymore simply because there's not enough spare capacity. So if you are going to enable HA in a cluster, then you can do it the old-fashioned way in the vSphere client. And I think lots of you still love to work with the vSphere client because the new web client is maybe a bit slow. It's a challenge to work with the web client. But who loves the web client? Okay, because all the new features are in there. Yeah.
5.1 is better now.
5.1 is a little bit better. Yeah. But I still see a lot of running circles. Yeah. So what do? You simply switched on HA, you configure the number of host failures allowed, and that's all. And this is where it goes wrong, because simply switching on HA is not enough. You have to keep in mind that every virtual machine has a slot size in an HA cluster when you are enabling host failures on HA. And the slot size is based on the highest reservation of a virtual machine for CPU and memory. Do you know what the default reservation is for a virtual machine? For memory? If you don't put any reservations at all on your virtual machines, what is the biggest reservation for memory in your cluster?
It's 0, isn't it?
0, nearly 0. It's the virtual machine overhead. The virtual machine overhead is depending on the type of OS you're running, the number of CPUs, and the amount of memory configured. So what happens if HA becomes active? The virtual machines are not magically migrated to another host. No, they will go down. And the virtual machines are powered on the other hosts. So how do you calculate the reserved capacity right there? How do you say, well, this is one host failure allowed, so I'm not able to power on virtual machines in the spare capacity, and I'm guarding myself against consuming too much resources? You do it by the slot size. Every virtual machine has a slot size. The slot size is based on the virtual machine overhead. And the virtual machine overhead for CPU is 32 megahertz, and this virtual CPU overhead for memory is, for instance, 69 megabytes. But these are very small figures. So if you are enabling HA by default, you put one host failure allowed, and you don't create any reservations, you have a lot of available slots. You can power on 47 virtual machines in this slot. And the total slots in the cluster are 222. You can imagine that a normal regular virtual machine is using much more resources than the default slot size of the HA cluster. But still you are allowed to power on a lot of virtual machines. So if you are enabling HA, you are configuring host values allowed, and you don't create any reservations, then it will go wrong eventually because you are powering on too much virtual machines. The reservation is 0, the default CPU reservation will be 32 MHz, and the default memory reservation will be the highest virtual machine overhead in the cluster. So if you have one 2008 server, then the 2008 server will dictate that there's 100 MB virtual machine overhead, for instance. Then the new SQL server is deployed, and the project leader of the new SQL server demanded 4 physical CPUs. He didn't want to run SQL in a virtual machine, but anyway, you persuade him that he must run in a virtual machine. So eventually, we want to run in a virtual machine. You know these guys, they're the project leaders, they're demanding physical CPUs, they're demanding real memory, and you have to configure settings you don't really feel good about. What happens is that the SQL server is configured with the reservation, a memory reservation of 1 GB. Okay, this means that the slot size of the whole cluster will be 1 GB. Every powered on virtual machine will occupy a space of 1 GB because that's the highest reservation. So you can compare it like a parking lot, and you know that somewhere a Hummer is going to be parked, so you have to design a parking lot. A lot of Daihatsu Fluoras are parked everywhere. They're occupying large spaces. Where's a Daihatsu? Nobody. But the Hummer needs to stand somewhere, so you're creating a lot of big slots. Every virtual machine occupies a complete slot. And what you see that is the number of available slots is 7. So you see the number of available slots decrease dramatically. And this is when people are starting to switch off HA. Because if they are powering on virtual machines, they will get the message insufficient resources. All the powered on virtual machines are occupying 1 GB. And you don't have enough physical resources to accommodate so many virtual machines with a full reservation. So people don't know how it works anymore, and they power it off. Okay, that's a pity. Can we do something about it? Yes, there are some advanced settings within HA that can influence the slot size. We can put in a maximum slot size and a minimum slot size. The maximum slot size is meant to cap a reservation. So if you have one virtual machine with a very high reservation, and you don't want to be that virtual machine the standard for the slot size of your cluster, then you can cap that particular virtual machine and say, well, I know there is a reservation of 2 GB, but the standard slot size in my cluster is 512 megabytes. You can also do the other way around. If you don't have any reservations at all, and you want to create a reservation, but not create a reservation on a virtual machine, but to create an artificial reservation to influence the slot size, you can hire this value, thus VM memory min MB. So it depends on the situation. If you have one virtual machine with a very high reservation, you can cap it. If you have no reservations at all, and you don't want to power on virtual machines, even though you don't have the resources anymore, you can hire a lower value. This is the slot size of your virtual machine, and you can influence it by hand. But there is a big but. Why? Because, first something else. You like the web client, there's something cool in the web client. Because these days we can set the default slot size in the web client. So the vSphere client had the advanced settings, so we had some sort of like a registry that can be used to put in those values. But now we have a slot size, so we can create a fixed slot size right here on the HA cluster. So even though you have high reservations, you can cap the size of your default slot and make it smaller. There's something else nice in the new web client, and it's the VM that require multiple slots. That's interesting. So I have that one particular SQL server. It has a reservation of 1 GB. My default slot size is only 512 megabytes. And I must guarantee that the SQL server is still powered on, even though the slot size of the cluster is less. And then this calculation comes into place. So the powered on virtual machines are measured, and if they don't fit in a standard slot, we have to put them in the VM list which require multiple slots, and you can generate that value after you have changed these values. Okay, so what happens if you are creating virtual machines, for instance in this case virtual machine 5 and 6, with virtual machine 5 with a double slot size, and virtual machine 6 even with a triple slot size, they will be reflected in the web client. The web client will show those virtual machines and will indicate that those virtual machines need multiple slots in order to be powered on safely after one of the ESX hosts is down. The other virtual machines still fit in a normal slot. You have to be careful with the startup order, and I'm going to show you what happens. If this ESX host is going down, and VM5 and 6 are hosted on this ESX host, the virtual machines are powered on the other hosts, but there can be fragmentation, and when DRS is active, DRS will help HA and will make enough slots available on one host to be able to power on a virtual machine. But when DRS is not active because your virtual center has gone down, there is a possibility that you have enough slots in the cluster, but because the resources are defragmented, the virtual machine is not able to power on. So I would recommend that virtual machines which occupy multiple slots get a higher restart priority. Then you know for sure that those virtual machines will fit because they are restarted at first. They will find its place. The small ones will start anyway, that's no problem, but the big ones really need those slots on one host and they don't need defragmented resources. So give those virtual machines a higher restart priority. Yeah, that virtual machine won't start. There's some other things to keep in mind, and sometimes I see people with a large HA cluster, for instance of 6 hosts, and they were telling me, well, we're going to buy a 7th host and we're going to double the amount of memory. Wow, that's cool, double CPU, double memory. But HA only looks at worst case scenario. So even though you are placing a new host in your cluster with a large amount of memory and all the other hosts have smaller amounts, then what happens is that if the small host goes down, the virtual machines are restarted on the other host. This space cannot be used in your HA cluster. So what you will see at the settings of your HA cluster is that you have available slots of 18. You have total slots in the cluster of 51, because we have 2 hosts of 16 GB and 1 host of 32 GB. So the amount of slots in the cluster has grown, but the available slots in the cluster is still 18. So it doesn't matter if you are creating 3 ESX hosts in the cluster of 16 GB, because you will still have the same amount of available slots. So keep in mind that if you are creating an HA cluster, all the ESX hosts need to be the same size. It doesn't help if you put one big host in a cluster, because the resources won't be used. They won't be used because HA only looks at worst case scenario, and if the big host is going down, the virtual machines must be restarted on smaller hosts. Yeah. So that's another takeaway. Only use the same sized hosts in your HA cluster. So the third thing is the percentage. Sometimes I hear other trainers speak about, well, percentage is great because the percentage doesn't look at slot size, the percentage look at the percentage of resources in the cluster. What they don't tell you is that it's the percentage of reserved resources per virtual machine that is taken into account. And a lot of people are putting in percentage, the message about insufficient resources disappears and they're happy. But I'm going to warn you, if you put in percentage and you don't create an artificial slot size, you will have the same problem. Because if you are configuring percentage, and in vSphere 5.1 you can do it both for CPU and memory in separate values, then you're saying, well, the HA cluster needs to reserve a certain amount of resources to be able to guarantee that virtual machines with reservations are able to power on. Sounds a bit tricky, but what you will see is that if I have 6 virtual machines, and those virtual machines are have a reservation, in this case 512 megahertz, then you will see that the current failover policy is 25%, the memory failover policy is 87%, and the virtual machines are powered on. And the fact that the virtual machines have a reservation will be taken into account. So the amount of reserved of the amount of capacity that is available to power on virtual machines is based on virtual machines that are powered on and configured with a reservation. So how many of you have configured all the virtual machines with a reservation? None. Okay. So what happens is that the default reservation of the virtual machine, there's the overhead again, will be responsible for the slot size in a percentage cluster. So what you have is a really weird situation. I have 6 virtual machines, the reservation is 0, the overhead of the virtual machine is taken into account as the reservation for the virtual machine. Those overheads are added up, and what do I have? I have a failover capacity of 79%. Sorry?
The high percentage there.
Yeah, really high percentage, incredible high, because it doesn't hurt to power on a virtual machine. Only the overhead counts for guaranteed resources. So guaranteed resources or a reservation is something completely different than consumed resources. If you are creating a PowerShell script, you want to take the consumed resources per virtual machine, and that are the resources that you want to subtract from the total amount of resources available in the HA cluster, not the amount of reservation. I'm not creating reservations on virtual machines. You know what happens if you put a reservation on a virtual machine and Windows boots? Windows will write all the memory to 0. And once the memory is touched, it cannot be used by another virtual machine anymore. So if you put a reservation on a virtual machine and the virtual machine doesn't use it, the memory is gone and it cannot be used by another virtual machine anymore. So be very careful with setting reservations on virtual machines. So how do we fix this? How do we create a situation where we are able to avoid this situation? You know what I have here? This is the most cool screenshot from your whole vSphere client, and it's the Drs Resource Distribution, because it gives you an insight in every single ESX host. It will show you how many virtual machines are powered on, and it will show you if the virtual machines are getting what they want, if the demand is satisfied. And what you see here is that I've powered on 6 virtual machines. My cluster is completely overloaded, but I still have a very high value right here of resources available in the cluster. Why? Every virtual machine only has a very small reservation. So if you are selecting percentage on a cluster, the virtual machine overhead or the reservation is taken into account. There are some secret settings, and those settings are not documented by VMware, at least not all of them. But the same thing we did for the host failures allowed is also possible for percentage. So you can create an artificial slot size for a cluster that is based on percentage. And what you're doing is that you're creating a higher reservation without setting reservations on virtual machines, and you will see the value go down. So you're guarding yourself in powering on too much virtual machines, and you are creating an artificial reservation in the cluster, and every virtual machine that's powered on has a reservation, but it doesn't hurt, because if the reservation isn't used, the amount of memory is available for the other virtual machines. So in this case we have a situation where we can use the advanced settings to influence the minimum slot size of a virtual machine and create a reservation on a virtual machine without creating a reservation. You know what? Do you get this? Yeah? Cool. Okay. So the web client is pretty cool, because the web client has a nice overview of reservations of all your virtual machines and the reserved capacity left in your cluster. So you can see all the virtual machines for CPU and memory added up, and you can see in one eye how many resources are available on this particular host or in this particular cluster. Sorry. So this is very important to keep in mind. The percentage is nice, but you have to create a reservation. This is the most cool admission control policy there is. Why? Because this is the only one that guarantees that virtual machines will be powered on again after you have lost a host. This is the specify failover host admission control policy. And you can designate a host, and that host will be reserved to power on virtual machines if one of the other hosts fails. This is hardly never used. Why? Because people are not telling to the, when an IT manager sees one host doing nothing, he says, what's happening with that host? Yeah, nothing, it's a spare host. So companies who are thinking traditional about failover are using this, but not the cool companies, because they want to use all the hardware. If this host is broken, or somebody forgot to create a port group on this host, you will find out when virtual machines are powered on this host. So you have to be careful, and you have to make sure that the configuration of this host is up to date, and that virtual machines are able to power on here. Don't forget port groups. If this host has a bad memory DIM or something, you will find out if virtual machines are powered on, because this host is doing nothing. So there are, you could swap the host every month and point a new designated failover host in order to tackle those problems. What happens is that a host goes down, you will lose all the virtual machines. The virtual machines are powered on the failover host. So there are some guys who think, wow, I've seen the ESX host with no virtual machines on it. That's mine. I'm going to use that for my little private projects. You are not able to power on virtual machines on the failover host. So if you are designating a failover host and you can do multiple, if vSphere 5.1, the host will be reserved as a failover host. So as soon as you try to power on a virtual machine on that host, you will get a warning, or you will get a failure message. And this is the warning you will get. So even though this host is part of a DRS cluster, you will still see that virtual machines are not migrated to this host. This is an exclusive failover host. And if you try to power on a virtual machine, it will tell you that it's configured as a failover host and it won't power on. You can also see the status of this host, and when it's green, there's nothing wrong. But when it's yellow, somebody has used the vSphere client, logged on locally to the host, and powered on a virtual machine. And that means that the host is not happy because it cannot guarantee that other virtual machines can be powered on, at least not all of them. So it's all about guarantee, satisfy the guarantee. If it's red, there's something else wrong. There's an HA error, or there's a host disconnected, or there's something else wrong. So monitor the color of your state, of your cluster, always, and try to look at the advanced figures. So the conclusion of the HA Deepdive regarding admission control is high availability needs to be configured. Don't just put one host failure allowed in or the percentage. Look at your slot sizes. You don't want to be your slot sizes dictated by someone who creates a reservation on an SQL server. You want to be in control of the slot sizes, and the slot sizes are very important for HA because they are saying how big the reservations are very important. Always check your runtime information. You have an advanced runtime button on your cluster, and you can see exactly what your slot size is, how many virtual machines are powered on, and how many space you have left. If you see all figures there, it must be a trigger, and you must think about, well, maybe I need to do something additional. Okay, so that was the first part. Any questions about the admission control?
Yeah. How would you change? Would you use different policies for different size clusters? So, for example, I've got 32 hosts in a cluster. One failover host may not work as well as a percentage, or vice versa. If you've got 3-host cluster, would you change your approach depending on that sort of size, or would the approach be unanimous across all of them?
If you are looking at percentage, then you can. And then you can do your math, and you can say, well, if I have 5 hosts, I need 20%. If I have 10 hosts, I need 10%. If I have 3 hosts, I need 33% per host. So you can calculate the amount of resources that needs to be available per host. If you have a 3-host cluster, and you are only configuring 25%, then you know that you don't have enough resources to satisfy the failover of all the virtual machines. So then the restart priority will become very important. But in big clusters, what's your SLA? What's your policy? How many downtime do you have? What's your RTO? What's your RPO? It's disaster recovery. And if you are guaranteeing the client that 2 hosts in the cluster can go down and his virtual machines are still running, then you need to configure 2 hosts or the resources for 2 hosts as a reserve capacity. Was that an answer to your question?
Yeah.
Other questions?
Yeah, if you have 3 hosts,
Yes.
which have roughly about 128 gig of RAM, if you add a 4th host with about 64, does that drop your overall resource?
If you have 3 hosts with 128 gigabytes of RAM,
Yeah.
and you're adding a 4th host with 64 gigabytes of RAM, it will definitely drop the amount of resources available. Because all the hosts will show that there are lots of slots in the cluster, but the available slots will be based on the smallest host. Sorry. So you had that situation, somebody found an old server and...
No, because in our environment, what happened is we needed an Exchange server, and we put in just one host, and sort of restricted that Exchange server to that one host.
Okay.
Yeah.
And that was the big host or the small host?
That's the small
The
host.
small host, yeah. Okay, okay. I would set it up as an isolated host.
Well, if you do that host build, then it's something to
Shit happens. So let's take a look at model 2, guys. HA data store heartbeats. A lot of people think that with HA data store heartbeats you can prevent host isolation. The management network is gone. Oh, it doesn't matter, we have data store heartbeats. Data store heartbeats will solve our isolation problems. There used to be a setting on a HA cluster, and the setting was power off all virtual machines when the isolation network, when there's isolation.
That was under 4.1.
Yeah, and it was still 5.0 I think, but they changed it in 5.1. They are now leave powered on, but they used to be powered off.
When the network disconnected.
Yes, yes. When the core switch was rebooted. So I had one situation with a cluster with 32 hosts, and someone deleted the VLAN ID of the management network. You know what happens? All the virtual machines on all the hosts are powered off. That's a lot. So I wrote a nice PowerShell script to power them on, but I don't have a PowerShell script for taking my phone. So be careful with the default isolation response. And heartbeats are not meant to prevent isolation response. So let's take a look at what the storage heartbeats are. If you look at your data stores, you will find out that there is a new folder in your data stores. It's an HA folder and it contains some obscure files. There's one file called the host XHB. And the host XHB, where X is standing for the object ID of your ESX host, is just standing there. It's doing nothing, it's very small, and it's just placed on your data store. The host XHB file is used to measure if your host is really powered on or really powered off. So when a host is isolated and you don't want to power on the virtual machines on another host, no worries. If your host is still powered on, the virtual machines will stay running on that particular host, and the host will post its living list in that particular file, because it will update a log on the file and the metadata is updated, and the master of your cluster can see that the host is still up and running. So these files are used for an alternate way of communicating for the master and the slaves. The master is able to check if a slave is really filled, or the master can see that the slave is still running, but there's no network connection anymore. There's another file, and this file is checked, and the master will check if the host is still active or not. And the VMFS on VMFS, the HA agent will check the livingness on NFS. The date is changed, and the date can be outdated if the date is not updated anymore. There's another file, and it's called the host X power on file. Every time you power on a virtual machine on an ESX host, that virtual machine will be placed on the protected list, because only powered on virtual machines in an HA cluster will be restarted on another host. But how can the master find out which virtual machines were powered on if the network connection between the master and the slave was lost? It can query the host power on file, and it can see which virtual machines were powered on or are powered on on that particular host. So if there is isolation, this file is used to communicate about virtual machines that need to be restarted on other hosts. In the early days of HA, there was a tremendous amount of stress on the VMFS because the master host was trying to power on all the virtual machines on another host, even though some virtual machines were left on the old host with the setting leave powered on. It tried to stall the lock and it didn't work because the virtual machine was still powered on and there was a lot of stress on the VMFS. So in this case, the host X power on file is used also as an alternative way for communication, and the master can learn which virtual machines can be powered on and which not. So I created what needs to be measured. If a slave doesn't respond, what do we want to know? Did it crash? Is there a network failure? Is the HA agent not reachable anymore? If we don't have any network, it's hard to find out what happened to a slave. But luckily we have now data for heartbeats, and it can be used to see what's really happening with the particular host. So this slide is heavily animated. I have a slave and I have a master, and you see some hearts. I was in a romantic mood. So what you see here is trouble in paradise. So the master is checking the slave is checking the master. Why is the slave checking the master? If the master goes down, the slave will elect a new master, and the server with the highest object ID will become the new master. But in this case, the slave is nicely checking the master, and the master is checking the slave. Okay, so then the man with the scissor comes by, and he cuts the management network of the slave. And the slave will try to connect to the isolation address, and the isolation address cannot be reached. The isolation address is default the gateway of your management network. And if it cannot be reached within a period of 12 seconds, then the host declares itself isolated. Why is the master not isolated? The master is still able to reach the gateway. So even though he's not able to reach the slave, he's still able to reach the gateway, so he knows that he's still connected to the network. The slave turns himself into a master, and he's now isolated. So the files on the VMFS, the data store heartbeat files, are not used to prevent isolation. They come into play when isolation occurs. And what you will see is that the new master, because he declared itself as a master and only a master can power off virtual machines, is going to power off virtual machines, and he's posting that information to the host X power on file. But first, the other master is checking if the host is still running, and we see that that's true, the host is still running. And this master will power on the virtual machine. It will post the information in this file. The other master is learning the information from the file and will try to power on the virtual machine on the other host. These virtual machines are only powered on if they are powered off in this file. So the stress we used to have on the VMFS is gone. The master won't try to power on all the virtual machines on the slave. It's just powering all virtual machines that are posted in this file. Once the virtual machine is posted in the file, it will be powered on the other ESX host.
Eric, how does it require the lock acquire the lock? Because the VMs are still running on both.
The VMs will be powered off.
They'll be powered off.
Yeah, by the old slave. By if you have, you can configure on a per virtual machine basis. If a virtual machine is powered off or leave powered on. If you are powering it off, you can do a hard shutdown, or you can do a guest OS shutdown. And once the virtual machine is powered off, and it can be the status of the virtual machine will be posted in the host X power on file.
It will be updated in that.
The master will learn that that virtual machine is powered off. It used to be powered on, it used to be protected, so it needs to be powered on again, but then on another host. So in most cases, I think that you leave your virtual machines powered on. Why should you power off a virtual machine? Because a host is not connected to the management network anymore. How long can you live without a management network? A week?
Until you get reboots.
Sorry?
Until you get reboots.
Until you get a reboot? Yeah. Maybe someone works at your desk and says, I want a new virtual machine. Well, I'm sorry, Virtual Center is not able to reach that particular ESX host. Virtual machines are still running, but I'm not able to reach it because there's something wrong in the network. So if you want to deploy a new virtual machine, then you might want to re-establish the network. So what I do as an alternative for, may I use your pen? What I often do is that if you have a cluster of, for instance, 3 ESX hosts, and you have your shared storage, normally the HA heartbeat network will travel over your management network. But what do you really want to measure if you are powering off virtual machines? Do you want to power them off based on the fact that the management network is not reachable anymore? Or do you want to power off the virtual machines because they are not available for my clients anymore? What you could do is on the switch that the virtual machines are using, create an extra port group, put it in a separate VLAN ID, configure with an advanced HA setting that you don't want to use the management network for your HA heartbeat, and let your heartbeat travel over the same physical infrastructure that is used by your virtual machines. Because if a physical switch goes down, then I have a reason to power on my virtual machines and power on the virtual machine on another host, because that host may be connected to the network.
Using promiscuous mode on the
Promiscuous mode on
the switch, so to be only internally.
Why should I use promiscuous mode on this switch? Do you want to see the traffic of other virtual machines? This is just an extra port group. So this is the port group of your virtual machines production. This is your HA lifeline. And the virtual machines are going here. This one is connected to a physical switch. The physical switch is connected to another ESX host. It's not redundant. This switch goes down. The HA lifeline is down. The virtual machines are powered on another host because it's still connected to a host with the valid switch. Yeah. So you have to think about what do I need to measure, and based on what fact do I want to power off virtual machines and power on another host. If the management network is down, it's not that interesting. I can live with a month without a management network. But if you really want to power off virtual machines based on isolation, then try to create isolation on the physical infrastructure that really matters. And that's the same infrastructure that is used by your virtual machines. Yeah? So in this case we have a real cool situation because the virtual machines are powered on the other host and they are running. So the conclusion of this module is that data store heartbeats are not used to prevent host isolation. Data store heartbeats are used as a sophisticated way of communication, and the master can really find out what's happening to the slave. Is it powered off? Is there another problem? Is it powered on but there's a network problem? Is the HA agent down? And based on that you can try to start virtual machines, but in an orderly way, because the virtual machines will be posted in the power on file, and as soon as the virtual machine is flagged power off, then the master is able to start that virtual machine again. If you don't want to power off virtual machines, leave them powered on. If you are going to power off virtual machines, keep in mind what you are measuring. Based on what fact are you going to stop virtual machines? Management network is not a valid reason. Try to measure the real infrastructure that is used by your virtual machines. So the data store heartbeats are able to make a distinction between failed, isolated, or partitioned, and not keep them from isolating. So, any questions about isolation? When my voice was good, I was asked by VMware to present a TV program, and it was recorded at both the VMworld in San Francisco and the VMworld in Barcelona. And together with Jeremy van Doorn, I presented VMworld TV. And if you're interested in the videos of VMworld TV, I would love to give you access, or you have to go to this URL, because there are a lot of videos, also real technical videos, posted on this URL. But they're real fun. So nice ladies in it. So apologies again for my voice. I think keep pretty well. I hope you all understand me. If you have any questions, please let me know. Otherwise, have a great London. Thank you.
Thank you.